Hello students, welcome back to another Greenfoot tutorial from Mr. Rowell for your grade 11 computer programming course. This is our first lesson in Unit 2, where we're creating a spaceship game, with the goal being that we can add some more interactability to our programming environments. We're going to have an actor. We've already played around with this a little bit, creating a spaceship that we control with the keyboard in some different types of ways. But we're also going to aim to interact with other things in our world. For example, create some enemies with unique behaviors and have some kinds of weapons to be able to interact with them. In the long run, you're going to know enough to be able to customize your own actors and enemies and all sorts of different unique interactions between them on your own. But for now, we're going to kind of step through this together to set things up in the first place and learn about how we can really make things more modular than we did before using a new idea called hierarchy. We'll get to that in the next tutorial. For now, let's make sure we set up our project in the right way with a couple new things that we're working with. I'm going to be going through the first part of your notes for today. During these tutorials, I'll be skipping over certain sections of your notes and allowing you to work through them on your own. I just want to highlight in here some of the big ideas that you'll be approaching so that it's clear enough as you go through on your own. Right now, I have the project that I'll be sharing with you. In it, you'll see, that's really small, that I have just the world constructor, pretty simple, and we have the hero class that was made with just the private variables of speed. Actually, I should get rid of this here. You don't need to worry about that for now. And it has the getter and setter for the speed variable that we talked about in class. It has an act method, which is accessing a process keys. Now, I have an alternative process keys option. So here I have two options for controls, and you can kind of decide which one that you prefer. Maybe you made your own custom one that you prefer. I would access that one. Leaving the other ones in my code lets me maybe access them later on or give the player an option for which control set they want to use. Might not be a bad idea to leave it in your code. And in a sec here, we're going to get down to this new thing called track mouse. In your notes, you'll be able to read a little bit more about this, but I want to point out a couple things to you. First, we have a new class that we're referencing called mouse info. And we're accessing the Greenfoot class and saying get mouse info, and it's going to return to us. If I pop open the API here, let's actually jump over to it. Should have had this open in advance, but that's okay. Good thing to remind ourselves how to get here. If I go under my Greenfoot class, it says get mouse info. It says it returns a mouse info object with information about the state of the mouse. All the info we need, the computer is going to send to us automatically about what the mouse is doing, where it's on the screen, if it's clicking or not. And it's a mouse info type object. This is the rules or the identity of that object. So I have to define it. I can name it whatever I want. MI for mouse info. I could have called this mouse info, whatever I want. But I'm going to just call it MI for now. And here's how the logic works. If MI does not equal, remember the exclamation equal sign? This means does not equal null. This means if it does not exist. It's a double negative, but remember sometimes double negatives are really useful for us in our coding. This is a fancy way of saying if there is mouse information, if we can detect that there's a mouse. If we don't have this logic set up, the program might crash depending on what information the mouse is sending. So this is the way we want to kind of set up our mouse gathering information logic. If the mouse does exist, if it doesn't not exist, then what do we want to do? We want this object, our hero, our spaceship, to turn towards some coordinates. And I can access some methods that my mouse info has. Note over here, if we go back to our API, we have a mouse info class. So now we have access to all these methods in here that get us information. Get X, return the current X position of the mouse cursor. Get Y, return the Y position of the mouse cursor. Other ones as well that you can experiment with on your own. But for now, this sends the information of exactly the X coordinate my mouse is at and exactly the Y coordinate my mouse is at. What we'll be able to see here is if I create an instance of my hero and hit run, it's not actually turning towards it. Why is that the case? Well, let's take a look back at our code here. All of this behavior is stored in a method called trackMouse. Am I actually accessing this method anywhere? think about it for a sec. Where should I be accessing this method in my code? In my key pressing? In my constructor? Where should it be? And the best answer is here in our act method. Each tick of the game, I want to track the mouse. So I'm just going to add a reference to this method in act. And now each tick of the game, once this compiles here, I'll add my actor back in. Wherever I move my mouse, my ship is going to automatically track it. And I can still move it around with the keyboard, but the rotation is now going to be adapting to wherever the mouse is pointed. Cool. This adds a whole new layer of interactability to our game that you can probably already think of many ways that this could be useful in a certain scenario of gameplay or interactability. Awesome. So now that we've got that set up, I want to recap one more thing here. Let's remember that when I press reset, my ship's gone. It's really annoying to have to put this in each time. So how do I get my world to remember? Well, I got to save the world. I'm going to drop my hero in. I'm going to say I want it to always start at this kind of the left middle. I could program this in manually, or I can simply drop it in here and right click and go save the world. Now, my world object, galaxy, is going to automatically prepare the adding of my hero at those specific coordinates. So my world did it itself, and I can just, well, maybe I don't like this number being 129, maybe I'll make it 130. It'll slightly adjust it so it's in a nicer, even number spot. And you could have done this manually by yourself, or you can just put it visually and click Save the World. Maybe, for some reason, you want to have two of them. I mean, you can do this again. This would be kind of weird, but let's see what this looks like. Now if I run it, they're both running with the same rules, so they're both following along, following the mouse. And okay, maybe not a very practical thing, but it's kind of cool to see that we can create different instances of that object. And now when I hit reset, I actually don't want that second one anymore, hero 2. I'm just going to remove it. I don't want that actually there. I just want my one hero. All right, so now I've created the logic to set up the initial game state. Whenever I press reset, it's where I want it to be. It has its mouse interactability going on. Wonderful. Let's add another layer to this. We are now going to consider adding in a projectile. There's some notes in your PowerPoint reading about projectiles. I recommend you pause the video and take a read through this slide and the next couple as well, just to kind of see what's coming up here. And once you're done reading it over, jump back to this video. Welcome back. So what we're going to be doing here is we are going to be creating a new class. Now, if you read really far ahead in the PowerPoint, you might know that what we're doing here is actually not the best strategy. We're going to be adapting things later, but it's always good to start simple. And we're going to be creating a class called Laser. Now, we're going to use the image I provided you for the laser. In the future, you can get all your own images for all your own objects. For now, I'm just going to create my own and pop open the code here. I need to consider what attributes does a laser in my game need? What types of things does it need to be able to do, to know? And we're going to define some of those initial things in our private attributes. First, I need it to have a speed, how fast it travels through my world. We're not going to really worry about the damage it does just yet in our code, but we'll set it up for later on in a future tutorial. It needs to be able to do some amount of damage. Think about this as different weapons do different amounts of damage so that your gameplay has some variety to it. Now, I'm just going to remove these comments here because I know what act means now. I don't need that reminder for me personally at this moment in time. And I'm going to create a constructor for my laser. Remember, a constructor is just public, the same name as the class. This is going to be the code that runs whenever a laser is created. And in this case, I want to, whenever I create a laser, to tell it information about its speed and damage and set these things in. And now maybe in this scenario, I want to say my damage for a laser is always 1. That's going to be hard-coded in here. But maybe my speed can be something that changes depending on if I have a power-up or something else. So I can define my speed as some information that is sent to the constructor. So different lasers can have different speeds, but they all have the same damage. That's how we think through how this constructor is constructed logically. Now, I've set some information about speed and damage, so I want to set some getters and setters. get damage. That tells me it's going to return the amount of damage this weapon does. And get speed. This is going to return the speed that my laser travels at. And maybe I want the ability to adjust these things later. I said maybe my damage is hard-coded, so maybe I won't have a setter or a mutator for damage, but maybe I do have one for setting the speed. Whoa, don't want my fingers stay there. And I can set my speed to whatever I receive in this setter. So if this is ever accessed, it's going to set the speed to a new number. I just want all this functionality there. I might not access these right now, but it's always good to have these getters and setters in place in case we need it later on in our code. I'm just going to put the spacing together here a bit. And now we need to think about what our laser needs to be able to do. So my action code. Things are being a bit laggy here. That's all right. I want my laser to be able to do two things. I need it to be able to move on the screen, and it's going to move at the speed that it's capable of traveling. I also need it to check for boundaries, because what's going to happen is if I shoot a laser, let's just think about this theoretically, if I shot a laser and it traveled straight, what happens to it once it goes off the screen? Well, if I don't give it any commands, what's actually going to happen is Greenfoot is going to continue to create the laser traveling off my screen. Totally unnecessary because I don't see it anymore, but it's going to still exist traveling infinitely outwards, every tick of the program calculating it again. If I shoot 100 laser beams, even though they're off my screen, I think they're gone, there's going to be 100 lasers traveling off to the right or wherever I'm aiming forever that my program has to keep track of. The more I shoot, the more bogged down my program gets with processing because those objects still exist. So what I'm doing with check boundaries is I'm going to create some code to when the laser or whatever I'm shooting reaches the edge of the world, it's removed, it's deleted because I don't need it anymore. It's not going to affect my game world. And in that case, the code will stop being processed and it'll free up some of the processing power for other things to be going on in my logic. Let's think about how we might define these. Now, these are both methods that don't exist inside this object yet, so I have to create them still. So down here, I'm going to create some space. I'm going to say public void speed, or move, sorry, move. And it, we defined up here, is expecting to get a number for speed. So we'll put the logic for moving later, but I want this to exist here. And I also want to have a custom method for checking boundaries. You can see in the PowerPoint the code to set this up. I'm going to type through it really quickly here and talk about a few unique instances of logic that we're utilizing to get this to be as generalized as possible. So how do I determine in my code if my laser beam that I create has hit the edge of the world? Here's how I'm going to think this through. I'm going to create a new Greenfoot image. And the image is going to be the same image that I'm using for this class laser. So this is basically assigning IMG the image of a laser. And I'm going to define a couple variables. Width is my image, its width, and the height is going to be my image height. So whatever image, like when I go in here and say set image, this ship laser, it has a width and a height to it in that actual PNG file. That is what I'm assigning to width and height variables here, so that I can use that a little bit later. All right, I'm going to jump down here. And here's where we're going to do something very important that we'll probably get confused about many times, but as we're continuing to learn, that's all right. I am going to access my world, because here's the thing. This laser is an actor. My world is separate from it. Okay, this is the place where everything lives in, but I don't have direct access to my world's information in my laser class. I have to access that by first telling the laser the world exists. So I'm telling the laser right now, the world exists. Let's call it I think I did in my other file, I called it lives in. So we're accessing the world's information. We're calling our local copy of the world lives in. And here is the method I use to get the world's information, get world. This is all the information that Galaxy knows, that our world knows. And now the laser is aware of it through a piece of information called lives in. Now, later on, I'll be able to access information about my world in my laser class because I've now brought that information, I've imported it in. Is maybe one way of thinking of this. I want my program to be able to understand when the edges of my laser are reaching the edge of the world. You might want to listen to this a couple times through by backing through it, but I'll talk it through once here. I'm going to be setting a bunch of different variables here. The left, and by this I mean the left of my image. Here's how I'm going to get the very left of my image. I'm going to run a method called getX. This is going to get the x coordinate of the very center of my image, well, of my class. My current laser, wherever it is, I'm getting its x coordinate of the very middle of it. To get the left side, it's the middle shifted the width divided by 2 over. Remember, the width is the width of my image. So this is half of the image width over. The x-coordinate of the middle of my image minus half of its width. That's going to be the very left edge of that image. In a similar way, right is going to be get x plus width divided by 2. That's going to be the center of my image plus half, the very edge, right edge of my image. Maybe you want to see if you can think for yourself how to do top and bottom. Hit pause if you want to try it yourself. Otherwise, I'm just going to continue here. Get y minus height divided by 2. And the bottom is going to be get y plus height divided by 2. So now these variables are storing the information for the very left, right, top, and bottom of my laser that's currently created here. Notice I didn't access through a period because I'm accessing the class I'm already a part of here, so I don't have to give it any class information ahead of it. I can just directly access the method for the class that I'm in. Nice. Now, here's where the logic kicks in. If the left coordinate, that very left edge of my laser, is less than or equal to 0, meaning if that is at 0x, meaning the very edge of the screen over here where x is 0, if it's equal to that or even past it, then here's what I want to happen. I want to access my world. The world that this object lives in, I'm accessing its information, and then here, in the world, I'm removing an object. And which object am I removing? I'm going to think about this for a sec. I want this laser that's been created to be removed. And in Java, we have a simplified way of doing this. My friend's playing Mountain Blade, cool. I am going to remove this. This is a keyword that means this current object that exists, only this one. I'm going to remove this object. So this laser, if it reaches the left edge of the world and it recognizes that it's just at or past the boundary, it's going to delete itself. And then I don't have to worry about that existing in my code anymore. It's gone. Now, what I want to say is else if right is greater or equal to lives in dot get width. Let's make sure we understand this once I close off my brackets here. If the right edge of my image, I defined up here, is at or bigger than the width of my world. So basically, if my laser has reached or passed this side, the entire width point, then, well, I want to remove this object. The reason I use an else if here is that if I just put this as an if, it actually would run the same, but here's the one difference. If my object reaches the left side of the screen, it gets erased. If I put this as an if statement, then this code gets run anyway. Although, in this scenario, this object would be deleted in the first place, meaning that it wouldn't actually be able to run. So this is actually just kind of a syntactical pattern that's good to follow. Stating else if removes any possibility that unnecessary code will be read. So in a scenario where this object would still be running after this, the else if means that if this happens, then this doesn't have to happen. So it saves some processing power. So for now, it's just the better way to do it. Else if. Let's continue. Top. Let's remember how the y coordinates work. The top is actually where y is 0. So if top is less than or equal to 0, we're going to remove this object. Or in our final scenario, else if bottom is greater or equal to the total height of our world. Lives in get height. All right, if this laser is below the total height, then it should be removed. Okay, that's necessary for this to happen. Now, one thing I actually want to come back here and talk about briefly is that Java has a built-in move logic for this. If we look at our API under actor, we have a method called move. The distance it moves this actor the specified distance in the direction it is currently facing. The distance is what's based off of our speed. If I wanted to later to customize how move worked, I could write my own special customized code here. But just having this normally, actually, I'm going to erase this for now because I just want it to move the way that Greenfoot automatically processes it, just using my speed as the way that it moves. All right, so we want to be able to test this out and see if this is actually working. So here's what we need to be able to do now, is that we have some rules set for how this laser behaves, but it doesn't yet exist in our world. We want to access this laser through our hero class. The hero is the one who's controlling when the laser exists and how it behaves and operates. So I need my hero to be able to shoot a laser. Time for another custom method. Public void shoot. Here are the rules for how the shooting is going to work with this laser. Whenever I shoot, I want a new laser to be created. I'm going to call it laser. It's a new laser, and remember when I create a laser, I have to send it a speed. Let's make it speed 5 for now. We can always adjust this later. Oh, go away updates. And I'm going to access my laser, and I'm going to tell it to set its rotation. Why I'm doing this is because my hero in the game is facing east, and the laser automatically is going to face east as well. What if my hero is facing up or left or some other direction? I don't want the laser always shooting to the east. I want the laser to adapt to shoot the same direction my hero is facing. So I want the rotation of my laser to be the same rotation as my hero. And I can just access getRotation method in my hero class to be able to set the rotation of my laser to the same as my hero. And that will fix that. I would play around with this a little bit to really make sure you understand what's going on here. It's a very important step to just have locked into your own understanding. Finally, I want to add this laser to the world. How do I add it to the world? I'm in my hero class. I don't have access to my world. I can do this. I can get my world. And now that I have access to it, I can add an object to it. Which object? That laser. And where do I want to add this object? I've got to have an x and y coordinate. Here's what I'm going to use for now. It's not the most sophisticated thing, but I'm going to add it right in the dead center of my ship, of my hero. I'm just going to get the x and y coordinates of my ship and add the laser there. So if I go over here and I hit run, everything's going to be working, but there's no laser. Well, I've got to think about this. I've now defined the rules for shooting, but I haven't actually put shoot anywhere in my program. So how do I want this to be able to shoot? Well, when I process my keys, I should have some kind of an interaction that causes the shooting to occur. So what I'm going to do is, let's just keep it simple for now. I'm going to add another key press check, another conditional, the space bar. If the space bar is pressed, I want my laser to shoot. And how is it going to shoot? It's going to create a new laser. It's going to set the rotation the same as my ship, and it's going to add to the world this laser at the center of the ship. And then the laser's logic is going to play out. It's going to be created, and it's going to, when it acts, it's going to move each time at the speed we set. At each moment it's moving, it's also going to be checking if it reaches the edge of the world to be erased. Let's see how this looks. Space. When the laser reaches the edge of the world, it gets deleted. Whichever way I'm looking, the laser is going to be shot. Now, one limitation if I would program this right now is that as long as I'm holding spacebar, the laser is being created every tick of the program. So it's a nice rapid fire weapon. Maybe we want to change that. We're not going to worry about that for now, but it is something to take note of. Also note the laser being created right from the middle of the ship. Maybe that's what we want, or maybe we want it to be shot from some other place, maybe it's somewhere along the wing or somewhere along the nose. That's all information we can edit later. For now, just make sure your program is able to have ship movement, and while pressing a key, it's able to fire a weapon that looks like it's actually shooting in the proper direction. And from there, once we're at that point, move on to the next tutorial, adding in some more weapons and thinking about how we can make our weapon additions and functions more modular. Enjoy playing around with it. It's pretty fun to get to this point. Many more steps to go, though. We're going to have some pretty cool stuff going on in the near future. See you in the next one.